Hello, we are Group 17, composed of Fabian, Stab, and Armando, and this is our PowerPoint and presentation for Lab 2. The purpose of this lab report is to create a circuit to measure temperature variations using an LM335 temperature sensor and record the temperature values in MATLAB using analog inputs and, of course, the Arduino board. The LM335 temperature sensors is very easy to use and it's very cheap and it's very accurate, compared to the price. The sensor is basically a center diode whose reverse breakdown voltage is proportional to absolute temperature. Resistors are also placed before the sensor and buzzers so there can be a bias and the sensor and buzzers receive current.
Okay, now on to the materials. Here we're going to be using an LM335 temperature sensor, as it was previously mentioned in the introduction. As you can see, this is the sensor right here. We will also be using a 2.2 kilo ohm resistor, which is this one, a 120 ohm resistor, which is this one, a 680 ohm resistor, and a 1 kilo ohm resistor. We will also be using the Arduino Leonardo as a mini computer to process everything, with the jumper cables to connect everything together. And we also personally decided to add a buzzer as a special thing to the circuit so it could announce when it reaches certain temperatures. We also have the LED as a signal for the circuit, and the lighter. The lighter we use to be able to reach the certain temperature for the temperature requirements of this lab. And we have a circuit board to perform all of our connections, and of course we need MATLAB to be able to write the code. Now on to the method. So the first thing we did in our method was prepare our board with all the resistors, sensors, and buzzers that we used that we're going to be using for the lab. And the first thing that we had to do is figure out what the analog signal is and how we were going to use it. And we found out that the analog signal is continuous in time and amplitude, and that there is no gaps between the signals that are generated. And then we also used the linear temperature sensor to be able to calculate the different temperatures in the room and also when the sensor was heated up. And we were successful to collect the data from the room and temperature in task 1. This is the circuit from task 1. Both circuits are the same, but this is the one from lab 1. And then in task 2, we're going to be using continuous temperature monitoring, which we are monitoring the temperature for 60 seconds when the sensor is heated and not heated, and you can see that the LED is blinking. Now to Armando.
So for analyzing the codes that we use for task number 1, here's the code. If we follow along with the notes that are here in the code, we can see that the temperature is being recorded for 20 seconds, but the sensor gives us the temperatures in kelvins. So there is a line to transform that Kelvin reading to Celsius, and then from Celsius to Fahrenheit, which we were supposed to give our temperatures in Fahrenheit. Here we record the temperature for 20 seconds, the room temperature, and at the end, the last 2 lines give us an average of the temperature in the room and a standard deviation for the temperature. An average will be an addition of all the readings divided by the amount of readings, and the standard deviation will be how much the readings differ from that average number. That is for task number 1. Our code for task number 2, if we can, we're gonna change that to task number 2. Our code for task number 2 will read the temperature for 60 seconds and then we can see a live reading for 60 seconds of the temperature. So we needed 3 fluctuations in that temperature. For the first fluctuations, we used fingers. We touched the sensor and the temperature changed a little bit. And that was not enough because we needed 3 different fluctuations. So for the second fluctuation, we used a lighter. We put the flame close to the sensor, whereas the temperature would jump up a little bit. Then for the third fluctuation, we just put the lighter closer to the sensor in order to read at even higher temperature, which made our buzzer beep as we had expected to do. So for the results of the lab, when discussing the results, as you can see in these two graphs, the first one shows the temperature for the room. The room temperature was about 72, 71 degrees, as you can see. And then the second picture shows the 3 fluctuations for task number 2. In overall performance, this circuit performed well. It performed as expected. And it was a little bit hard sometimes to use the lighter, especially trying to avoid any other components in the board. But other than that, there was no other complications. The lab was successful. Everything worked as expected. The LED behaved as we needed it to do. And for the most part, it was a really successful experience, and we learned quite a bit from it. So now to Fabian to discuss the conclusions of our lab.
Okay, so to summarize everything, the lab was very successful. We managed to do everything as intended. Our knowledge of circuits came in very handy because by using the lighter, as he said, we could have damaged other parts of the board. So we added the little buzzer to let us know if we go past a temperature that was safe for all the equipment. So that was very useful. And yeah, that's about it. It was a very successful lab. Now to Armando to show the actual circuit.
So now here is a description of the circuit. So we are going to click start, run our code. And if we look at our circuit, the LED light will be on because it's below the certain level that we wanted it to be. And here's the reading on the temperature. If we put our fingers on the sensor, the reading on the temperature will change and start to rise with our body temperature. It starts to rise. After it rises above a certain level, which that level is set to 70 degrees, the LED will start to blink. In order to see that even more clearly, we will use a flame in order to show how the temperature will change. The LED is blinking now, and if the temperature gets even closer to a certain level, the buzzer will go off, indicating that the temperature went above 150 degrees. So as you can see, the circuit behaves successfully. Once the temperature is still above 70, the LED is still blinking as our reading continues to go. So the circuit functions and works successfully, and everything went as expected. Other than that, that's our conclusions for the lab. Thank you very much.
Thank you.
Thank you.
And